In this class, we are going to discuss about the operation of the buck converter. Buck converter is a DC to DC converter. The output voltage will be less than the input voltage. If you see the circuit diagram, this is the DC input voltage which is represented by the Vs. This is switching device. This is the freewheeling diode which is connected across the load. This is the inductor. This is the capacitor. This is the voltage across the inductor. This is current passing through the inductor. This is current passing through the capacitor. The voltage across the capacitor is equal to the load voltage V0. This is the positive direction of the load current. By controlling the on and off state of a switching device, we can control the output voltage which is less than the input voltage. Now we are going to see the circuit operation. Here we have taken the scale. On the x-axis we have taken the T. This is the T on, nothing but on time of a switch, off time of a switch. This is the total time period. In that manner, we have taken the two time periods. This is one time period, this is the another time period. First, we are going to represent the input voltage Vs. That is constant with respect to the time. That's why we have taken the constant line. Now we are going to see the how the inductor current will be changes. When switch is on, this voltage is applied to the inductor through the load in this manner. Now the current is passing source, inductor, load, again return to the source. In this interval, the inductor current will be increasing from minimum value to the maximum value. When switch is off, the current is passing from load, freewheeling diode, inductor, again load. Nothing but in this duration, the current is changing from maximum value to the minimum value. Again here minimum to the maximum, maximum to the minimum. If we see the inductor voltage, when switch is on, apply the KVL in this loop. So Vs minus VL minus V0 equal to 0. Find the value of VL. VL equal to Vs minus V0. This is positive because output voltage will be less than the input voltage. When switch is off, now the current is passing in this manner. So the inductor voltage will be equal to the load voltage which is negative. So VL equal to minus V0 because this negative is connected to the positive of a VL, whereas the negative of a VL is connected to the positive of a load voltage. If you draw the inductor voltage, this is Vs minus V0. When switch is off, minus V0, again Vs minus V0, again V0. We have taken the load current as a constant load current. Now we are going to draw the capacitor current. Apply the KCL at this node. The entering current is IL. The leaving currents are IS and I0. So IL equal to IS plus I0. You find the IC, that is equal to IL minus I0. IL is nothing but inductor current, where I0 is nothing but a constant load current what we have assumed. So this is the current waveform of load current. This is the inductor current waveform during the on and off state of a switch. At every instant, you have to subtract the inductor current from the load current, that gives the capacitor current. At t equal to 0, the load current is more than the inductor current. So capacitor current becomes a negative. This is the positive direction of the current. Capacitor current. Negative current is nothing but the current will be passing in this manner, opposite to the reference. So the capacitor will be discharging when the negative capacitor current. Positive capacitor current is nothing but capacitor will be charging. So at t equal to 0, the capacitor will be discharges up to this point where load current and inductor current both are equal. So from this point, the inductor current is more than the load current. So we are getting the positive again up to here. This positive capacitor current is nothing but a capacitor is charging in this duration. The negative capacitor current is nothing but the capacitor will be discharges in this duration. Now complete the waveform. The voltage across the capacitor is equal to the load voltage. Now we are going to draw the load voltage or capacitor voltage. When the capacitor is discharging, nothing but a load voltage will be decreasing from the maximum to the minimum value. When the capacitor is charging, capacitor voltage or load voltage will be increases to the maximum, from minimum to the maximum, again from maximum to the maximum. In this manner, the load voltage will be oscillating between the maximum value and a minimum value. There is some amount of ripple will be existing in a capacitor voltage or the load voltage. To find the average output voltage here, we are using the inductor volt second balance equation. From the inductor volt second balance equation, the average voltage across the inductor, this is the voltage waveform of the inductor, the average voltage across the inductor becomes a 0. So to find the average voltage across the inductor, we have to see the how the voltage across the inductor is changing. This is positive voltage, this is negative voltage. So this positive voltage into T on, that gives the area of this curve, minus V naught into T off, that gives the area of this curve, divided by the T, that gives the average voltage across the inductor, that is equal to 0. Now cross multiply this one, we are getting the Vs minus V naught into T on minus V naught into T off equal to 0. See here, V naught T on, V naught T off. Take common V naught. So Vs into T on minus V naught into T off plus T on. This is equal to the T. So substitute the value of T also. You find the value of V naught. V naught equal to Vs into T on by T off plus T. This we can write it as a delta into Vs, where delta equal to T on by T off plus T on. This is nothing but a duty cycle of the switch. So the duty cycle of the switch is defined as a on time of the switch divided by the total time period of the switch. Variation of the output voltage versus duty cycle. We know the expression for the output voltage V naught equal to delta into Vs. The delta we can change from 0 to 1. So on the x-axis we will take the delta equal to 0, delta equal to 0.5 and delta equal to 1. This is the maximum value of the duty cycle. See, in this delta you take these three values and find out the corresponding output voltage. We are getting the 0, 0.5 Vs, Vs. We line join the 3 points, that gives the linear graph. As delta is changing from 0 to 1, the maximum output voltage we can get it Vs. The delta less than the 1, the average output voltage will be less than the Vs. So that's why we are calling this converter as a buck converter. The output voltage will be less than the input voltage. So thank you very much for watching this video.